everyone. Today I am going to tell how to find N of A union B union C and Venn diagrams and solutions of miscellaneous exercise problems from NCERT. If you take an example like this, in a class the number of students can speak only English A. If you see this Venn diagram you will understand. Only English A and only Hindi B and only Bengali C and only English and Hindi. Only English and Hindi, that is D, and only Bengali and Hindi, that is E, only English and Bengali, that is F, 3 languages, that is Z. So if you assume like this, then the number of students who speak English, that means this is the number of students who speak English. So they can also speak Hindi and Bengali also. So that is N of E, that is equal to A plus D plus G plus F. See the difference here. The number of students who speak only English is A, but the number of students who speak English, that means they can also speak H and B. And here only E is A, that we assumed here. Just check here. Only English is A, but they can speak English. The number of students who speak English is A plus D plus G plus F. So N of E is equal to A plus D plus G plus F. Similarly, if you take N of H is equal to B plus E plus G plus D, and N of B is C plus F plus G plus E. And the number of students who speak at least one language, that means minimum one language they can speak. So that is N of E union H union B. That is, if you add all these values, then you will get this value. So N of E union H union B is the number of students who speak at least one language. So that is A plus B plus C plus D plus C plus F plus G. This is fourth one. And if you see here, N of E intersection H is D plus G. This is N of E intersection H. And only English and Hindi is D. But both English and H is D plus G. This is the difference. Only English and Hindi means they cannot speak Bengali, so that is D. But if you take both in English and H, that is D plus G. This is the difference here. So N of E intersection H is D plus G and N of H intersection B is E plus G. Similarly, N of E intersection B is F plus G. And this value, N of E intersection H intersection B is G. And from 1 to 3, these are, if you add all these three values, N of E plus N of H plus N of B on left side and right side, then you will get A plus D plus G plus F. You add all this. From this, if you write separately A plus B plus C plus D plus E plus F plus G, because I just cancel like this, because you have to write separately here. Because here fourth one is this one A plus B plus C plus D plus E plus F plus G. So that is N of E union H union B. So you have to write separately. And here D plus G, the remaining are D plus G. Why? Because here we know that N of E intersection H is D plus G. So write separately this one also and E plus G. And here there is only F. So write add plus G and subtract G. So plus G minus G. Then A plus B plus C plus D plus C plus F plus G is N of E union H union B. So write this value plus here D plus G is N of E intersection H and E plus G is N of H intersection B plus F plus G is N of E intersection B minus G is N of E intersection H intersection B. So now from this you can write easily N of E union H union B is equal to, you have to write N of E plus N of H plus N of B minus N of E intersection H minus N of H intersection B minus N of E intersection B plus N of E intersection H intersection B. So this is the number of students who speak at least one language, minimum one language. Now, if you want to calculate the number of students who speak exactly any two languages, that means only any two languages. So if you see here, for example, only English and Hindi, only these two languages, they cannot speak Bengali. Those students are D. Here only Hindi and Bengali E and only English and Bengali F. That means they cannot speak other languages. Only these two languages they can speak. But if D plus G, N of E intersection H, that is D plus G, means they can speak these two languages as well as they can speak the other languages also. So that is the meaning of this one. And so here you have to find who speak exactly any two languages, means only this portion, that is shaded portion, this one you have to calculate. This one and this one. So that is D plus E plus F. So that is equal to D plus E plus F you have to find. But here we know that N of E intersection H, that is D plus G, and N of H intersection B is E plus G. Already I told this. So these are the values here. And here only you have to find D plus E plus F. So you have to add G here. So here D plus G and E plus G and F plus G. So you are adding here 3 G's. So you have to subtract 3 G's. So minus 3G. So now you can directly write D plus G is N of E intersection H. So write here N of E intersection H. This is the value. And E plus G. So this one N of E H intersection B plus F plus G, that is N of E intersection B minus 3 N of G is E intersection H intersection B. So this is the you can find the value of the number of students who speak exactly any two languages by using this one. Now the next one, the number of students who speak exactly one language, only one language. So those are A, B, C. So here the number of students who speak only, they can speak English are A. So here only Hindi B and only Bengali C. Here N of E is full students. So they can speak English as well as other languages also. So here N of E, and the difference between N of E and only English means only English they can speak. They can speak only English. Those students are A, and N of E is full. You can add A plus D plus G plus F. That is the difference here. So here you have to find only exactly one language. They can speak exactly one language. So only this value or this value or this value. So you have to find A plus B plus C. So these are the students. They can speak exactly one language. So either English or H or B. So you have to find ABC values here. So you know N of E is A plus D plus G plus F. So A plus D plus G plus F is equal to N of E. From this A is equal to N of E minus D plus G plus F. That means D plus G plus F. From N of E you have to subtract these three values. That is A. And B, N of H minus you have to subtract these three values. So write D plus G plus E. C is equal to N of B, this one full, minus F plus G plus E. These three values you have to subtract. So these are the three. You have to write first one, this is second one, and this is third one. And from these three, if you add all these three, A plus B plus C, now add all these three, N of E plus N of H plus N of B, minus here 2D and 2Z, 2E, 2F and G. There are 3 Z's, so you can write 2Z plus G again. So like this you can write here. And now N of E plus N of H plus N of B minus, you have to write 2 into 2 is common here, D plus G. Why? Because here we know that N of E intersection H is equal to D plus G. That's why you have to write this separately. So 2 into D plus G, and here 2F plus, here 2 into D plus G plus 2F plus G, only 1 G. So you have to add again one more G and subtract one more G plus 2E. So you have to add plus 2Z and subtract again 2Z. That is minus 2G plus 2G minus 2G. Here plus G minus G. Okay. So now write again all these values, minus 2 into D plus G plus here 2F plus 2G. So 2 into F plus G minus G and 2 into E plus G minus 2G. That is N of E. Write all these things. Now minus 2 into D plus G, minus into plus, minus 2 into F plus G, minus into minus, minus into plus, minus 2 into E plus G. Now minus G minus 2G is minus 3G. So minus into minus 3G plus 3G. Okay. So write like this. Now this you have to write all these things, and this one you know that 2 into here D plus G, that is N into E intersection H. Similarly, minus 2 into N into H intersection B. So you have to write all these values. So by using this, you can find the number of students who speak exactly one of the languages. And now, if you take any three sets of ABC, so N of A union B union C, you can find by using this N of A plus N of B plus N of C. Here minus N of A intersection B minus N of A intersection C minus this is plus. I have to use this, and the number of elements in exactly any of two of the sets. So that means exactly any two of the sets, that is, you have to use this one. And number of elements in exactly one of the sets. That means exactly one language, here any two languages, exactly one, any two languages. This is one of the sets, means exactly one language. So similar to that. So you have to use this one. Please remember all these three, how to find these values. Now I am going to tell how to find number of elements from the Venn diagram. For example, here given values are N of A is equal to 26. That means N of A means is full. And N of B, these are the given values. N of A intersection B means this one, full 9 plus 5. And these values are given here. And we have to find N of A union B union C by using this Venn diagram like this. First write this value. Here, this value is N of A intersection B intersection C is equal to 5. So write this value here. And if you want to calculate the number of elements, only common for AB. Only common for AB means this AB only. So only you have to calculate this, and only for BC and only for AC. So that you have to find N of A intersection B minus N of A intersection B intersection C. That means here N of A intersection B is given, that is 14. So here this full value is 14. So you have to subtract 5 from 14. Then you will get this value. So here N of A intersection B is 14. 14 minus this 5, that is equal to 9. So here only A and B, that is 9. And only B and C. That is, here now B intersection C is 12. So 12 minus 5, that is 7. So you have to subtract 5 from this value. And again, you have to subtract 5 from this value. 10 minus 5, that is 5. So like this, you can calculate these values, these three values. And now you can calculate the number of elements in sets. That means you have to calculate these values. Okay. So here only A. For only A, you have to first take this N of A. Here N of A is given. See here N of A is equal to 26. So N of A is equal to 26. So from N of A, you have to subtract these three values. So N of A minus 9 plus 5 plus 5. That is 26 minus 19, that is 7. So this value is 7. And next one is N of B is given, that is 31. 31 minus these three values. See here, that is 10. So you can calculate 10 here like this. And only C, that means only C, N of C minus N of C is 20, that is given. So 20 minus these three values. 5 plus 5 plus 7, that is 70. So 3. So first you have to write this value. Then you have to calculate these three values. Then you can calculate these three values. Okay. So once you calculate all these values, you can find N of A union B union C is equal to, you have to add all these values. 7 plus 10 plus 3 plus 9 plus 7 plus 5 plus 5. So you can calculate like this. So the total here is 46. N of A union B union C is equal to 46 here. This is example 34 from NCERT. A college awarded 38 medals in football, 15 in basketball, and 20 in cricket. If these medals went to a total of 58 men and only 3 men got medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? So here 38 medals. So in football, the men got 38 medals, in basketball 15, and in cricket 20. So let F, B, and C denote the set of men who received medals in football, basketball, and cricket. So here N of F is equal to 38, and N of B is equal to 15, and N of C is 20. And here the total of 58 men. So N of F union B union C is equal to 58. And only 3 men got medals in all the 3 sports. So here all the 3 sports. So N of F intersection B intersection C is equal to 3. And here you have to find how many received medals in exactly 2 of the 3 sports. Exactly 2 of the 3 sports. So you have to use this one, the number of elements in exactly any 2 of the sets. You have to use this N of A intersection B plus N of B intersection C plus N of A intersection C minus 3 into N of A intersection B intersection C. So you have to use this to find that value here. So first write the given values here. These are the given values. And here N of F union B union C value is given. So use this one, N of F union B union C is equal to, we know that here this one, N of A union B union C, you know this. So use that one. And here substitute all the given values here, except these 3 values. Remaining all values are given here. So substitute those values. Then you will get the total of these 3 values. That is N of F intersection B plus N of B intersection C plus N of F intersection C is equal to here 76. This total is 76 minus 58, that is 18. So the total of these 3 values is 18. This is first one. And here you have to find the men who received medals in exactly 2 of 3 sports. So now use this one, N of F intersection B plus these 3, add these 3 minus 3 into N of F intersection B intersection C. So you are using this one because here exactly any 2 of the sets. So exactly 2 of the 3 sports, a similar one. So you have to use this. So now substitute this value. Just now we got this value, that is 18. 18 minus 3 into this value is 3, that is given in the problem. This value is 3. See here, this one. So 18 minus 3 into 3, that is 9. So the men who received medals in exactly 2 of the 3 sports is 9. Either you can do like this or you can use Venn diagram to find the value. So here N of F union B union C, by using that we will get this value, N of F intersection B plus N of B intersection C plus N of F intersection C is equal to 18. So this value we got from the Venn diagram. Here this value is given, that is Z for example, and let us assume these 3 values. This is only F and B, that is D, and only B and C, that is E, and only F and C, that is F. So here exactly any 2 of any 3 sports means you have to add these 3 values, D plus E plus F. So you have to find these 3 values sum. So from the Venn diagram, we have to find D plus E plus F. So from this N of F intersection B, so N of F intersection B is D plus G, this value. So instead of this, you can write D plus G, and N of B intersection C is E plus G. So E plus G, and N of F intersection C. So that is F plus G. So F plus G is equal to 18. From this, D plus E plus F plus 3Z is equal to 18. D plus E plus F is equal to 18 minus 3 into 3, that is 9. So this is this value. Therefore, the men who received medals in exactly 2 of the 3 sports is equal to 9. So you can find either this way or the previous method you can use like this also. So any way you can do. These are the miscellaneous exercise problems from NCERT. This is question 15. In a survey of 60 people, it was found that 25 people read newspaper H, 26 people read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, 3 read all 3 newspapers. So find the first one is the number of people who read at least one of the newspapers. Second one, the number of people who read exactly one newspaper. So here there are 60 people. They surveyed for 60 people. Out of those, it was found that 25 people read newspaper H. So that means let these people who read the newspaper, those people, the set of those people be H, and the set of the people who read the paper, newspaper T, those are T, And similarly, the set of the people who read the newspaper I, those are I. So let HTI be the sets of people who read newspapers HTI. Then here N of H is equal to 25. And here N of T is 26. N of I is 26. And both H and I. So N of H intersection I is 9. And both H and T. So N of H intersection T is equal to 11. And T and I, both T and I. So N of T intersection I is 8. And 3 read all 3 newspapers. So N of H intersection T intersection I is equal to 3. So once you write all these values, here you have to find the number of people who read at least one of the newspaper. That means minimum one paper they have to read. So those people you have to find N of H union T union I. This is the value of this. So for this you have to find like this. First write the given values here, all these values. And the number of people who read at least one of the newspapers is equal to N of H union T union I is equal to N of H. We know this, N of H plus N of T plus N of I minus N of H intersection I minus N of H intersection T minus N of T intersection I plus N of H intersection T intersection I. So substitute the given values, these values here. See here, N of H is 25. So substitute all the values here. Then you will get the answer as 52. So this is the number of people who read at least one of the newspapers. So if you observe, they surveyed 60 people. So that is universal set. So N of U is equal to 60. So 60 minus 52 is equal to 8. So 8 people do not read any newspaper. So 52 people, at least one paper, then they read. 8 people, they do not read any newspaper. Or we can do the same solution by using Venn diagram like this. Here, these are the given values. Then from the Venn diagram, so first write the value here. This is the value 3. This is N of H intersection T intersection I. So first write this value 3. And here you have to find the number of people who read only H and T. That means you have to find this value. Only H and T, that is here N of H intersection I is equal to, sorry, this is N of H intersection T is equal to 11. So 11 minus 3. You have to subtract 3 from this 11. This is full. H intersection T means is full value. So 11 minus 3, that is 8. And only T and I, that is equal to T and I. This is 8. 8 minus 3, that is 5. This is 5. And only H and I. So H and I, that is 9. 9 minus 3, that is equal to 6. So this value, 6. 8, 5, 6. These are the values. The number of people who read only these two papers or these two papers like that. And once you find that, then you have to find these values. So the number of people who read only H means this value. So this you have to find by N of H. N of H means this full. So N of H minus, if you subtract these 3 values from this, then you will get this value, right? So N of H, you know that N of H is equal to 25. So 25 minus 8 plus 3 plus 6, that is 8. Similarly, N of T, that is 26. 26 minus, you have to subtract these 3 values, 8 plus 3 plus 5, then you will get 10. Similarly, only I. So that is N of I is 26. 26 minus, you have to subtract these 3 values, then you will get 12. So these values are 8, 10, 12, and these values are 8, 5, 6. So this is already given. So if you add all these values, then you will get the number of people who read at least one of the newspapers. So just add all these values, 8 plus 10 plus 12 plus 8 plus 5 plus 6 plus 3, that is equal to 52. Either you can do by using like this, or you can do by using Venn diagram. So this is the solution. And next question is from the same problem. They asked the number of people who read exactly one newspaper. So exactly one newspaper, that means only one. So for that you have to use this one. The number of people who read exactly one newspaper. You can see from here the number of elements in exactly one of the sets. So you have to use this. So You have to use that n of h plus n of t plus n of I minus 2 like this. So now substitute the given values in this, then you will get 30. So these are the number of people who read exactly one newspaper. Or you can do the same question by using Venn diagram also. So already you got all the values previously I told. So these values you already got. So just add these values. These are the people who read exactly one newspaper. Therefore, the number of people who read exactly one newspaper is equal to 8 plus 10 plus 12. That is 30. You can do like this or you can do like this. This is 16th problem. In a survey, it was found that 21 people liked product A, 26 liked product B, and 29 liked product C. If 14 people liked products A and B, and 12 people liked product C and A, 14 people liked products B and C, and 8 liked all the 3 products, find how many liked product C only. So here let A, B, C be the sets of people who liked products A, B, and C. So here n of A is given, that is 21, n of B is 26, n of C is 29, and both A and B. So n of A intersection B is equal to 14 and C and A. So 12, that is n of C intersection A is 12 and here B and C. So n of B intersection C is 14 and all the 3 products, the number of people, that is 8. So n of A intersection B intersection C is 8. So here you have to find how many like products C only. Only C you have to find. So first write the given values here. Here all these are given values. From the Venn diagram, you can find easily. See here. So here you have to find this value. Only C, the number of people who like product C, only C. So you have to find this value. This value is given and you have to find first these 2 values and n of C, you know, that is 29. So if you subtract these 3 values from n of C, then you will get this value. So first find these 2 values, only these 2 values. So from the Venn diagram, the number of people who like products only B and C, because you have to find this value only B and C, that is n of B intersection C is equal to 14. So 14 minus, you have to subtract this value. 14 minus 8 is equal to 6. So this value is 6. And only A and C, that is 12. 12 minus 8, that is equal to 4. So once you get these 2 values, now you can find the number of people who like the product C only is equal to n of C minus 4 plus 8 plus 6. N of C is 29. See here, n of C is 29. So 29 minus 4 plus 8 plus 6, that is equal to 10, 18. That is 11. So the number of people who like the product C only is equal to 11. Now practice these questions. These are the answers.